Hello everyone, I hope you all are doing well. Welcome back to the AWS AI Engineer Essential series. My name is Dheeraj Choudhary and today we are diving into data preparation for machine learning with Amazon SageMaker Data Wrangler. So let's get started. Let's start with the fundamental truth about machine learning that surprises many beginners like you. In real world machine learning projects, data scientists spend approximately 80% of their time on data preparation and only 20% on actually building and training the models. This might seem backwards to you. Shouldn't the model be the hardest part? But the reality is that getting clean, well prepared data is far more challenging and time consuming compared to running the training algorithms. Now, the remaining 20% of time goes to selecting the algorithms, tuning hyperparameters, training models, and evaluating results. Modern machine learning libraries could and cloud services have made this part relatively easy. You can train a sophisticated model in minutes, but preparing the data to feed into that specific model, that's where the real work happens. There is a famous saying in machine learning, garbage in, garbage out. You can have the most advanced algorithm, the most powerful GPU, and the best hyperparameters, but if your input data is messy, incomplete, or properly not prepared, your model will perform terribly. A simple algorithm trained on high quality, well prepared data will always outperform a sophisticated algorithm trained on poor data. That is why data preparation is the most critical phase of any machine learning project. Master data preparation and you will be successful in machine learning. Rush through it and your models will fail, no matter how much you tune them. Understanding this upfront sets the right expectation and priorities for your machine learning journey. Now, let me walk you through the complete data pipeline that transforms the raw data into model ready data. First is the collection, where you gather data from various sources. This might be pulling records from databases, calling APIs to fetch information, reading CSV files from storage, or scraping websites. Or you can also collect sensor data from IoT devices. So, real world data comes from messy, deseparate sources and rarely arrives in perfect format. So the first phase for you is always going to be data collection, which is this phase, where you are going to interact with a lot of different sources. It can be databases, APIs, files, scraping if you want. So this is where from where your data comes in. Then comes step two, that is exploratory data analysis, or also known as EDA, where you actually look at and understand your data. You generate statistics, create visualization, check distributions, identify patterns, and spot anomalies with the data that you have collected in your previous step. This step answers questions like, what does my data look like? Are there any missing values inside my data? Are there any outliers inside my data? What relationship exists between the variables, that is the columns which is there in our CSV file? So EDA is going to guide all the subsequent decisions based on this. Then comes pre-processing, which involves cleaning and transforming your data into a consistent, usable format. This includes handling the missing values by imputing or removing them, removing duplicate values, correcting data types. Many a times for the date column, the data type is given as string, but the right data type for that should be date and time. Normalizing or scaling numeric features to get them into a similar range, and encoding categorical variables into numbers that model can process. Then feature engineering is where you create new features from existing data to help your model learn better. This might mean extracting the day of week from a timestamp, combining multiple features into ratios, creating polynomial features, or applying your domain knowledge to craft meaningful indicators. Good feature engineering often matters more than the algorithm choice. Validation ensures you prepared data which meets the quality standard before you invest the time for training the models. You check for data leakage where future information accidentally appears in training data, verify distribution, match expectation, confirm no missing values remain, and ensure features types are correct. This final quality check prevents costly mistakes that you can make. So let's understand the different types of data sources you will encounter and the challenges they will present in front of you. The structured sources like relational database are the easiest to work with. So Amazon RDS for transactional data, Redshift for analytics, or traditional SQL databases provide data in a neat row and columns format. You write SQL queries to extract exactly what you need, and the data arrives with clear schemas defining column types as well as the relationship. Now, semi-structured data like JSON logs from your application, API responses, or XML configuration files have some organization but lack rigid schemas. You might get user activity logs as JSON where each event has different fields, or API responses where optional fields appear inconsistently. This requires more parsing and handling of variable structures. Now, unstructured data includes images from cameras, text documents like emails or reports, video from surveillance, CCTV, or audio recordings. These have no inherent table structure. To use them in machine learning, you must extract the features, maybe using computer vision to detect objects in images. Now, NLP can be used to extract topics from the text, or signal processing can be used to extract patterns from the audio files. Now, challenge includes dealing with different file formats and encoding across sources, managing access permissions and credentials to various systems, and handling highly variable data quality. Some sources have clean, validated data, like we saw, which is from structured sources, and others can be errors, duplicates, and missing information. So, your collection strategy must account for all these kinds of variation. So when I showed you the collection part in my previous step, you might be thinking this is the easiest one, but no, that is not the easiest one. This is the kind of challenges you're going to get when you're going to work on the collection of data. Now, for EDA, which is your first step into deep diving inside the data that you have collected, so over there, statistical summaries gives you the basic characteristics of numerical features where it calculates the mean, median, and standard deviation to understand the central tendency and the spread of that specific feature that you are looking forward for. So you can check minimum and maximum values to spot impossible values like negative ages or ages above than 150, which is impossible. Count unique values in categorical features. These simple statistics reveal a lot about data quality and their distribution. Now, distribution analysis shows you how your data is spread. Create histogram from numerical features to see if they are normally distributed or skewed or have multiple peaks. Use box plots to reveal outliers where you can see data points that fall far outside the typical range. So correlation analysis identifies relationship between the features. So highly correlated features might be redundant if you square footage and number of rooms have 0.95 correlation, you might only need one of them. No need of having multiple features which are very correlated to each other, especially in terms of 0.95 correlation score. Then comes the missing value detection, which is very critical. You need to know which columns has the missing data, how much is missing, and whether missingness follows a pattern. If 50% of the income values are missing only for customers who didn't complete purchases, that's informative. If data is randomly missing, you can impute. If it's systematically missing, you might need different strategies. So missing value detection does not mean that you will directly go ahead and remove those columns. No, you have to understand the pattern behind those missing values and the use case. Now, pre-processing transforms messy raw data into clean, consistent data ready for machine learning. So in the previous step that I have showed you for EDA, we understood what are the shortcomings in the data. Now comes the phase where we are going to fix that with pre-processing techniques. Handling missing values is often your first pre-processing task. You impute missing values by filling them with mean, median, or mode of that specific column. For example, if a age is missing, fill with the median age. Alternatively, you can remove rows with missing values. Though this risks also losing valuable data, some algorithms can handle missing values natively, but most cannot. So you must address this kind of missing value issue. Then outlier treatment deals with extreme values that could skew your model. If you have house price mostly between 100K to 500K, but three houses are at 50 million, so those outliers dominate the learning for your model. So you can remove them entirely or cap values at reasonable maximum price like 99th percentile, or apply transformations like logarithms to compress the scale of that specific data. The right approach depends on whether outliers are errors or genuine extreme values. Now, scaling and transformation ensures all numerical features are on similar scales. If one feature ranges from 0 to 1 and another ranges from 0 to 1000, the larger scale feature dominates the distance based algorithms. So, standard scalar transforms features to have mean 0 and standard deviation as 1, and min-max scalar squeezes features into 0 to 1 range. So neural networks and distance-based algorithm require scaling, while tree-based algorithms like XGBoost don't require it. Encoding converts categorical variables into numbers since machine learning algorithms only understand numbers. One hot encoding creates binary columns for each category. If color is red, green, or blue, you can create columns with one indicating the presence. So as if I come to the screen and suppose if we have red, green, and blue. So you can have different types of numbering over here. Either you can have 0 for this and 1 for the other values. So in case if it is green, then it will be 0, 1, 0. If it is blue, it will be 0, 0, 1. If it is, it can be 1, 0, 0. So this is how you can do it. Otherwise, you can do the other way around, where you can say the value for red is going to be 0, for green is going to be 1, and for blue it is going to be 2. So there are two ways of doing it. So you can use one hot encoding for nominal categories with no order. So where we know there is a order, we can do the nominal category, and we can use label encoding for ordinal categories with natural ordering. So for example, if you see small, medium, and large, don't you see there is a natural ordering over here from top to bottom or bottom to top? So this is known as natural ordering. So at that time you can use label encoding. Now feature engineering is where you apply creativity and domain knowledge to improve your model's learning ability. So derived features extract useful information from existing features. A timestamp contains year, month, day, hour, and day of the week, all potentially a value. So you can extract a day of week from transaction time because shopping pattern differs between weekdays and weekend. So if in the date you have these specific items included, so it will be day. So my day is going to be, suppose I say it is going to be 03, my month is going to be 10, and my year is going to be 2000. Now you have to understand that based on your use case scenario what you need. Do you need the day, do you need the month, or do you need the year? So if you are looking for any one of them specifically, then you can extract them from this entire thing, that is from this column, that is an existing column, and you can make a new column out of it, which is known as derived features. Then interaction features combine two or more features to create one new ones. So for example, in e-commerce, price and quality individually matters, but price times quality equals order value, which might be more predictable for customers. So in that case, you can create a new column where you can combine both of them. So we will say price into quantity and we'll create a new column that is total. So that is how you can create an interaction features. So this is going to be a new feature, remember. And the same way as I showed you previously, suppose if I say I want day, so it is going to be a new feature extracting from the existing one. Then aggregation compute statistics over group data. So for each customer, calculate their average purchase amount, total lifetime value, purchase frequency, or days since last purchase. So for these time series, create rolling averages. So that is how where you are going to use aggregations, which is known as group statistics. Then comes domain specific feature where you leverage your business or field knowledge. So in credit scoring, debt to income ratio is known as important indicator. In manufacturing, temperature change rate might matter more compared to the absolute temperature. In healthcare, BMI is medically meaningful. So based on that, you have to understand what kind of new feature you are going to engineer. Then now let's introduce SageMaker Data Wrangler, which makes data preparation visual and accessible without coding. Now, Data Wrangler is a visual interface integrated into SageMaker Studio where you prepare data through point and click operation. So instead of writing the code, you are going to just drag and drop. So for example, in SageMaker, once you go inside SageMaker, you might have a canvas. So in this canvas, you just have to say that, suppose if I want to associate, to get data from an S3, that is our starting point of collection. So I will just drag and drop the S3 in the canvas. Now, if I want that to be associated to do any transformation, then I can add a transformation over here. And then by using the plus sign, I can add n number of transformation number 1, 2, 3, 4. And that is how SageMaker Data Wrangler helps you prepare your data in the SageMaker Studio. The tool includes over 300 built-in algorithms or transformation covering all common data preparation needs. You can handle missing values, encode categorical variable, scale numerical features, filter rows, a lot. So for each transformation, you select options from menus rather than writing transformation code. Now, for SageMaker Data Wrangler, after this tutorial, I am going to post a project in which I am going to do end-to-end all the steps that has I have mentioned over here, from collection, EDA, feature engineering. So now just understand the theory, what exactly SageMaker Data Wrangler is. And in our next video, we are going to do a hands-on demo end-to-end. Then comes Data Wrangler. So Data Wrangler can import multiple sources without leaving the interface. You can connect S3 buckets and read CSV or Parquet files. You can query Amazon Athena to pull data from data lake. You can connect to Redshift data warehouses, Snowflake databases, or even third-party databases. So the interface is going to handle authentication and data loading, so you can focus specifically on preparation of your data. Perhaps the most powerful feature in Data Wrangler is auto-generating production-ready Python code for everything you do. After usually building your data preparation workflow, you can also export it as a Python script or a SageMaker pipeline. This means you prototype your flow visually, get quick results to understand or validate whether it is working as per expectation, and then deploy exactly the same logic to production without manually rewriting or transforming your code. So Data Wrangler includes powerful built-in tools that make EDA, that is exploratory data analysis, and quality checking effortless. So the data quality report is one of the automated analysis that scans your dataset and generates a comprehensive report. It detects anomalies like outliers or unusual patterns, identify all missing values and shows percentage, checks for duplicate rows, warns about target leakage, whether future information leaks into features, and suggests potential issues. So when you are in SageMaker, what you will have to do is you have to just trigger this data quality report, and it is going to get all of this just I discussed inside one report you can analyze that. So quick model is a fascinating another feature that trains a simple machine learning model on your data in seconds. It shows feature importance, which features are most predictable for your target that you have selected. Suppose if I am working on a regression problem, I will give one specific target based on the use case that I have. This helps you decide which features to keep, which to engineer further, and which might be a noise that you should remove. You get model performance metrics to understand if your problem is even learnable with current features. It's fast sanity check before investing in serious modeling. Built-in visualizations let you create histogram to see feature distribution, scatter plots to examine relationship between features, and correlation matrices to identify highly correlated features, and bar charts for categorical breakdowns. These visualizations appear instantly as you explore your data, helping you understand patterns and guide transformation decisions for you. The natural language transformation feature is powered by AI. So instead of clicking through and selecting what you want to do, you can just type convert temperature from Celsius to Fahrenheit or extract month from date column. And the data wrangler is going to generate the appropriate transformation code for you. So in data wrangler, now there will be a button for Amazon Q. If you use that, just give your requirement and it is going to create the transformation based on your requirement. Now let me walk through a typical workflow in Data Wrangler from start to finish. So first comes import. So importing is your starting point. You connect to your data source, whether that can be an S3 bucket, database query, or data warehouse. So data wrangler shows you a preview of your data. As soon as you load your data, double click on that, it will show you the table with which all columns are there, what are the data types of that specific columns. It even shows you small histograms to see the distribution of that specific column with hundreds of rows, so you can verify it loaded correctly or not. And you can sample larger data sets. So suppose if I am going ahead and I have a data set which is having 50,000 rows. Now while loading, if I have to do some analysis, I am loading, I can take a sample. So what I can do, from 50 I can just take a sample of 5,000 or a sample of 10,000, and based on that I can start with my analysis. Now transform is where you spend most of your time. You select a column and choose from hundreds of transformation. Maybe you encode a categorical feature, scale a numerical one, or create a new feature by combining two other features as we saw. So after each transformation, you immediately see a preview of the results. This instant feedback lets you quickly try different approaches, undo your mistakes, and refine your preparation steps. Third, you analyze based on your data at any point in the workflow. Run the data quality report that we just discussed previously. So this is what the data quality report, the first one that I am going to talk about now. So when you run the data quality report after initial import of your data to identify issues, it creates visualization to check if your transformation worked as intended. Did scaling actually normalize the distribution? It use quick model after feature engineering to see if your new features improve predictiveness. So there is a lot of things which comes as part of this report, and this analysis guide your next transformation decisions too. Then you can export it as a final step where you're satisfied with your prepared data. You can generate a Python script containing all your transformations that you have selected as part of this pipeline, which is useful for running the same preparation on new data. And you can export directly to SageMaker pipelines to automate your entire machine learning workflow. Now, there are other options also where you can do, but in our next video, which is the hands-on demo, we will be exporting it onto S3. Now, it is not only exporting after making all this different steps. You can also split your data into train, validate, and test. And then you can push them into three different folders on your S3 bucket. And then when you're going to run the training, you can just point to a specific folder and it is going to pick the data from there. This is how powerful it is. And you are going to do all of this visually without generating any code. And if you want to use the output as a code, you can do that. It is going to go ahead and give you the Python script that you can use in your notebook and do the further testing. Now let me share critical best practices that prevent common and costly mistakes in data preparation. Always split your data into train, validation, and test sets before applying any pre-processing transformations. If you scale or encode the entire dataset first, information from your test sets leaks into training through the scaling parameters. The correct order is split first, then fit transformation on training data only. Then apply those fitted transformation to validation and test sets. Document every transformation you apply and why you made that specific choice. Data preparation is full of decisions: how you handle missing values, which outliers you are going to remove, what features you are going to engineer. Without documentation, you won't remember your reasoning in next 3 months, and colleagues can't reproduce your work. So Data Wranglers helps you by auto-generating code that serves as a documentation, but you can add comments explaining your rationale why you are doing it. Validate your assumptions and transformation with domain experts. If you're working with the medical data, have a doctor review your feature engineering. If it's financial data, check with analyst. Domain experts catch logical errors that appear statistically sound, like treating a categorical ID number as continuous or creating features that would be available at predictive time. Keep your raw data unchanged and always work on copies. Raw data is your source of truth. If you discover an error in your preparation pipeline, you can go back to raw data and start fresh. If you override your raw data with transformations, you have lost the ability to try different approaches. So storage is cheap, losing your original data is expensive. Now, thank you so much for watching. I hope you understood the end-to-end flow of our specific data wrangler. So we are going to, in our next video, we are going to do a hands-on demo while I will show you each and every step. So thank you for watching and I will see you in the next video.